Welcome to the channel, everyone. My name is Chad. I run the channel Chapman Cars and Tech. I started the channel when I got my 2019 Subaru WRX STI and realized Virginia is not a good place for car enthusiast content creation. So I started to do more tech videos instead. I have a computer science degree, minors in mathematical science and computer engineering, and I'm going to make more computer related content while throwing in some car stuff. So today in this video I'll be talking about solving problems in computer science that requires multiple cores or network computers. Example of problems that we'll be talking about here would be things that require some kind of simulation, or modeling. We also know that GPUs have many cores, so an application for solving distributed problems exists there too. And using a distributed method speed things along a lot, especially when you're processing graphics using floating point numbers. So let's begin with a drawing on how this would look like. So let's say you have, cores or computers with many cores. So we'll just draw out the computer as boxes. And then there will be network together, and then you might have some kind of computer that is a controller. Just to make sure that everything works the way it needs to be. So in today's discussion, we'll be talking about a math problem that can be solved in two different ways quite easily. You can do it using a distributive net method or a quick and easy shortcut that requires a little bit of multiplication. But the distributive network will assume that we have hundreds of computers that can only do add and not do multiplication. And this particular problem was first solved by a guy named Charles Gauss. He is a mathematician that came up with things like Gauss's law and physics. When he was a elementary school student, he got into a little bit of trouble with his math teacher, and he was asked to write or solve the following math problem: 1 plus 2 plus 3 plus ... plus 100. This is an example of adding up a set of positive integers, or it's also called the natural numbers. Natural numbers is basically the set of integers beginning at 1 and going so forth to positive infinity. Before I continue, I had to make a correction. His name is actually Carl Friedrich Gauss. So what he did was he started to do what the teacher asked, which is a good natural first approach. So begin to add 1, 2, 3, 4, and he started to notice some things. And what he did was he let this entire sequence of numbers, so we'll just do let S be the sum. We'll just sort it down to 10 for this discussion. 1 plus 2 plus ... plus 10. So what he did was he took that sequence of numbers, that sum, and just made it equal to S. 1 plus 2 plus ... plus 10. And I can't remember exactly the story of how he figured this all out, but he had another sequence, S, but in reverse order. So he started with 10 plus 9 plus ... plus 1. And then he just added it together, just like you would do 3 plus 1 equals 4. Just like that. So add a plus sign here. So you get 2S equals 11 plus 11 plus ... plus 11. Okay? And I don't think he knew anything about algebra back then. I'm not sure exactly how the curriculum was back in the 1800s, 17 and 1800s. So what he did was he noticed that there was a pattern that you have all this 10 times. So he basically went and said 2S equals 10 times 11. S equals 10 times 11 over 2. S equals 110 over 2. And S equals 55. So if you look at this right here, you can notice that there is some sort of a pattern, and it could be actually represented as a formula. A summation formula. K equals 1. This is where you're beginning with, up to N. That's your goal for, in this case, that's 10. And you can write it as N times N plus 1 over 2. Let's plug in 10 right here. So 10 plus 1 over 2 equals 10 times 11 over 2. 10 over 2 equals 55. Now, this right here you can actually prove it using a method called mathematical induction. This is a little bit more advanced for this type of discussion. I can review my notes and demonstrate it in another video if you wish. But that's just the gist of how everything can get put together, and you can actually prove that this formula will work for any n. So let's go back to what we were talking about. Let's say that we have this problem, we want to solve it, and we're using a computer, a very simple computer or a set of computers, but they can't do multiplication. So what you can do is represent the problem as 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. And you break it down into smaller pieces. So you give one computer 1 plus 2. The next one, 3 plus 4. The next one, 5 plus 6, 7, 8, and 9, 10. So now you ask computer 1 to add 1 plus 2, you get 3. 3 plus 4, 7. 5 plus 6, 11. 7 plus 8 is 15. 9 plus 10, 19. And now you have the answers for all these problems. And now the controller will say, we got all these numbers here. Let's redistribute these mathematical problems back to the available computers. So you have 3 plus 7. 11 plus 1, 5. And the fourth one, or the third one, we'll just keep that in memory. We don't need it right now, but we will need to do something with this later on. So 3 plus 7 is 10. 11 plus 15, that's 26. And then 19. Do the same thing for 10 plus 26. That'll be 36. And just bring down 19 and give it to another computer. And then you get the answer. Let's do it like this so we can show that everything is working the way it should. So 9 plus 6 is 15. 3, 4, and 5. And you have the answer 55. So there you go. So that's the end of this discussion. Hopefully you have a better understanding on how we can distribute problems over many computers or many cores to increase the speed on how they can be solved. If you like this video, please like, share, and subscribe, and we will see you next time.